Hey, good morning. Thank you, Ms. Anita. Our first speaker is a highly experienced structural engineer based in Singapore. He is a certified building information modeling manager by Singapore's Building and Construction Authority. He was accredited as ASEAN Engineer in 2017 and eventually an ASEAN Chartered Professional Engineer 2 years later. He has worked on several projects in Japan, Malaysia, Philippines, and Singapore, and served as president of PICE Singapore chapter in 2018. Currently, he is the BIM manager of Asia Projects Engineering Property Limited. To share his knowledge about the topic, BIM for contractors, value added on design and build projects, let us all welcome Engineer Romualdo Lex Garcia.
Okay, thank you so much, Ma'am Marilu. And thank you so much to everyone. Again, good morning. I hope my audio is clear. I would like to take this opportunity to thank everyone for inviting me to be part of your webinar. This is one of the first, I think, CPD webinar by PICE Iloilo, and we are really glad to be part of this initiative. As mentioned earlier, I would be I would be sharing on the topic BIM for contractors, value added on design and build projects. I am emphasizing the term design and build because as we all know, as we progress in our practice, we will realize that we have various projects. So we have primarily a design, bid, and build project. And also we have design and build projects. So what I'm going to share today mainly is on the value added in using or implementing, adapting building information modeling and virtual design and construction for contractors. So as we all know by now, BIM is applicable not only to a certain stage. It is applicable starting from the schematic or the design towards the detailing, towards the construction process, and even to the FM or facilities management. So it is applicable there. But today, I hope everyone is still awake and very much interested to hear out what are these um, factors that could add value for contractors. Okay, again, I'm Romualdo Lex Garcia. I'll be your speaker for first speaker for this session. In addition to the one mentioned by Ma'am Marilu, I am currently the BIM manager. I have 15 years experience in oil and gas EPC projects, but I started actually as a shipbuilding and offshore design engineer, more on structural steel design. And eventually, I was able to gain experiences on not only in design, but also on structural fabrication, 3D modeling. Of course, we're doing our design ever since 2006. We're doing our design using 3D softwares, although it varies from project to project, but we're emphasizing that one. And also, as we go along as we progress in our career, we would be able to experience how to handle a project and eventually be able to develop more appreciation on how we're going to deal with various kind of projects. So I am a proud Agustinian. I graduated in 2005. And although I'm a shipbuilding design engineer, I have decided to pursue Masters of Engineering in Structural Engineering in 2014 before I was offered a job or a work in Malaysia as a senior structural designer for the first tension leg platform uh, in Sabah area. Then 2 years or so, I was able to transition from doing offshore projects to infra project, being one of the structural engineers and also handling the BIM management of this project. So, and, and recently I have finished my specialist diploma in virtual design and construction, um, granted by Building and Construction Authority here in Singapore. So I would really like to share those um, knowledge, especially that the VDC is the one being used by or very much applicable to contractors, which I am currently involved in a main contractor company. So, okay, so much for this. Oh, by the way, if you want to connect with me in LinkedIn, you can scan this code here. Let's connect and be part of our network, even to those students and other professionals. I would gladly accept you as part of my network in LinkedIn. Okay, for the career timeline, I think we'll just go through this. I was born 1983, so I'm currently 38 years old. Graduated in University of San Agustin, 2005. Got my civil engineering degree, license in 2005 also. Then 2006 and 2014, I work as structural design engineer in Tsuneshi in Cebu. Um, I 2014, I was a candidate for senior structural design engineer, but I decided to transfer to Malaysia. During my term here in Tunisia, I was sent 3 times, basically 3 years assignment in Japan in 2008, 2010, 2013. Then I studied Master of Engineering 2013 and 14 before I transferred to Technic Malaysia. 2015, I transferred to Dynamac due to draft of oil prices. There's a problem during that time. So I was able to uh, become a structural engineer and a structural checker in Dynamac. These are offshore platform projects. So basically from shipbuilding, this is still oil and gas, but we're still doing, we're still using these 3D softwares. We're using Tekla, Navisworks, but this is a fabrication company. So it is a builder. So I was able to develop my skills in steel fabrication with the codes and correlating it with the design knowledge I was able to get. Then 2017, I was able to um, get the CN engineer registration by AFEO, then also accepted as a um, full member of ASEP, Association of Structural Engineers of the Philippines. 2008, I was transferred in Semcor Marine, and 2019, transferred to APECO as the structural and BIM manager. Then during that time, I got my certification in BIM management and also my ASEAN Chartered Professional Engineer accreditation in structural design engineering. And last year, I attended this course on Certified Digital Project Management or DPM by SK Knowledge Academy MIT. It is a very helpful course wherein we could really appreciate the linkage between softwares and best practices digitally. So especially if we're trying to transition from our traditional workflows and processes to a more digitalized one. So this is a very good course. And just recently, I finished my specialist diploma in virtual design and construction. So to start with the outline for today, we have the um, BIM fundamentals and BIM in Singapore. Actually, if you were able to attend my previous webinar here in PICE Iloilo, some of the topics would be reviewed in this segment. So before we fully dive into the benefits to our contractors, we should at least review or understand a little bit more on BIM fundamentals. Just a review if you're really familiar already. Then also I'll be sharing some info on BIM in Singapore on the perspective of a main contractor. Again, next is we're going to discuss the design bid build projects versus the design and build projects. Later on, we will understand why we are emphasizing this one. We need to compare these two before we could fully appreciate the later part, which is the BIM for contractors. So that's a thing to look forward. Next, I'm going to give you an introduction to BIM execution plan or BEP. So if you're a project BIM manager, you are you are obliged or you are required to prepare this document. Actually, this is the Bible of BIM projects. Those practitioners familiar with project management, this could be considered, the BEP could be considered as the project brief, wherein a lot of information is being placed there as guidance as how we're going to tackle the project as a whole from start to finish. But this one, the BEP is more on the BIM aspect, what softwares to use, what are the workflow, etc. So we're going to introduce this one. I hope you're going to be interested in this. When I got the offer of a BIM manager 2.5 years ago, this is the first thing they asked me. Luckily, I was able to present well what should be the content of a BIM execution plan. So yeah, it's a good thing aside from our knowledge on softwares and processes, this is one very important document we need to prepare. And also, if you're not the BIM manager or a BIM coordinator, you also need this document. You also need this document. Why? Because this is your guide. If you're the modeler, if you're the BIM engineer, or if you are the BIM coordinator, this is the document you're going to refer to at any stage of our project. So as much as possible, we're trying to capture a lot of things and put inside this document. So I would gladly introduce you to this document later on. Then afterwards, I'm going to present to you some actual example of a BIM VDC workflow. This one is the actual project that I have presented in my specialist diploma course, one of our activities and assignments. So I was able to relate this one as we are going to discuss the CNS design and build project. So again, later on, hopefully you're going to get a better picture of why there's a huge difference between the design build and the design and build project. Okay. Afterwards, upon showing this workflow, I'm going to discuss the benefits of BIM for contractors. Actually, this is a common knowledge already if you're already starting your BIM journey. So benefits of BIM for contractors, but I'm going to show you some usage of some softwares, particularly Navisworks Manage, because that's one of the software we're using on these two projects I'm handling. But I'm going to focus only on the coordination and clash checking. Um, I'm going to share some videos on how to operate this one, but we'll just go quickly as this lecture or webinar is not focused on the usage of that software. But anyway, it is a very good tool, especially we can get this for free, the Navisworks Freedom. But we're going to focus on the Navisworks Manage. And also, I'm going to share some of the 4D and 5D capabilities of this software. Next, we're going to discuss a little bit on the BIM coordination, just to emphasize, coordination meetings and model reviews. But this one, actually, we will be covering the importance once we dive in on the actual BEP. So later on, it's the actual BEP of the project that I was handling. That's what we're going to dissect more or less. Then, of course, we're going to go into the summary and conclusion, or the closing remarks of this presentation. But I'm going to give you some bonus clips or videos, just 2 minutes, 3 minutes clip regarding the DfMA, what are the future of construction, DfMA and PPVC, which is actually gaining traction here in Singapore. So it's very interesting, not only for civil engineers, but most especially to structural engineers and MEP professionals. So that's what we're going to expect here. So let's move forward. We're going to um, deal with this as quickly as we can. This is just a review. So what is BIM? This is the BIM life cycle, or we could also call this BIM information, building information modeling management. So what are the applications? Of course, as we have always emphasized, BIM is applicable to ANAs, renovations, also programming, conceptual design, detailed design, going to analysis. Actually, most even when I'm a student, I'm really fascinated with analysis and design. I bet majority of our attendees, or a lot of our attendees today, are really interested in this one. But this is going to be a different topic. There's a beam analysis. So next, the documentation. Once we have the detailed and we have analyzed it, we already have the properties, etc. Of course, we can generate our drawings. We create our shop drawings, fabrication drawings from this detailed design. So later on, I hope it is part of the presentation of Sir Marvin for the second topic. So next, of course, once we have a very good model and a good documentation or drawings, we are really assured more or less that the fabrication would be a smooth compared to the traditional flow that we're using. Then, of course, the construction. This one are the additional ones, the construction 5D and 4D, which is simulations. Then the logistics and operation maintenance. So BIM again, it is an intelligent 3D model-based process. So again, BIM is not a tool. BIM is not a software. BIM is not a program. BIM is the process. So within that process, we are also involved. We as the professionals are involved, civil engineers, mechanical engineers, our friends, electrical engineers, MEP, HVAC, etc. These professionals are involved in this BIM process. So again, we're trying to delete that connotation that BIM is the software. No, it's not. So it is a process that gives our key engineering and construction professionals, so AEC as we call it here, commonly here in Singapore, professionals the insight and tools to more efficiently plan, design, construct, and manage buildings and infrastructures, because a lot of softwares, a lot of processes could be used, applicable to structural engineers, applicable to designers, applicable to fabricators, MEP designers, MEP fabricators, even the electrical, also in the project management. So there are a lot of tools that are really designed to be interoperable. So meaning they are cohesive. So BIM is the middle, the nucleus. So these are the professionals involved in a construction or design project, usually the archi, the PM, the institution, the control institutions, the fabrication, detailing, engineering, and design. Control institution, most of this includes also those regulatory boards that, of course, we need to comply with in all of our projects. Okay. So again, just to emphasize, BIM is a process which going to deal with three dimensions. Okay. We could not really highlight this so much, but this is the reality. What is seen usually for the BIM deliverables are similar to an iceberg. We could only see the 3D visualizations, the coordinated drawings, and basic quantities. And what are the BIM requirements? We could only see the software, hardware, and training. But what is important is here below. We can have the thermal studies, lighting analysis, structural analysis, constructability, fabrication, asset, etc., photogrammetry. So there's so much to learn and so much to utilize in the BIM and VDC process. Why? Later on, I will try to explain the cohesiveness or the relationship between BIM and VDC, why we always mention them hand in hand. Okay? So, okay, these are the value of BIM to the owner, more informed decisions, better performing buildings. Of course, if you can really, use a 3D model to conceptualize, then this better performing, especially if you can have those lighting analysis, sun rays analysis, etc. Okay, thermal analysis is also possible if you really have a good model. Then, of course, efficient handover. If you have this CDE, the common data environment, then the gathering of the information, even from the start to end of the project, is really, really efficient. Unlike the usual practice that we have, the traditional one, gathering of info is really time consuming. So the efficiency is really low. Then for Archi, of course, the production of well-coordinated documentation. Actually, these documentation are termed for the drawings. So if you have a very good model, you have a very good site concept, you can create also a very good, well-documented, well-coordinated drawings. Then also you can allow model checkers to assist quality control. Most of the time, that's why we're emphasizing the CDE. Our 3D model is accessible by all those professionals that we have highlighted earlier. But of course, limiting the access rights. If I'm a structural engineer and I need to see the architectural model, I can do that within that CDE. So I can make a better and sound decision, especially on moving these columns, on changing the sizes of these beams, and I could communicate well with other parties. So that is one good thing with this. Then study multiple design alternatives. So this one is the conceptual aspect. Then of course for structural, same, good structural drawings, integrated modeling analysis. Yeah, this one, if we could really practice this, because it's a different topic. We can have modeled in Revit, transferred to an analysis tool, example to Autodesk Robot or to STAAD Pro or ETABS, then change, once we run the analysis there, we change the sizes, and subsequently we can put it back in our Revit model. A Revit model we can extract, or even in Tekla, we can do that also. I hope it's going to be emphasized by Sir Marvin later on. Okay, then of course clashes. This will incur, you know, some of these clashes might incur additional cost impact or redesign reworks, etc. So with these costly clashes controlled, minimized, or even eliminated, then it is already a benefit to the project money wise. So for the MVP, same thing, the documentation and accuracy of the bill of materials cost reports. Of course, the clash detection. More or less, we are doing clash detections between, although we are practicing internal or within that discipline, our clash detection usually is applicable to discipline versus another discipline clash detection process. So again, how did the BIM evolve? Started from handwriting, it evolved into 2D CAD. During my university days, we're really fascinated with using AutoCAD during the second semester. After we are really, after we struggled in our drawings or templates using the handwritten hand drawings. Then eventually this evolved. 2D CAD, then Autodesk was able to offer the 3D CAD. But this doesn't have any properties, so it is not really a smart object, just an object. But eventually, it evolved into the BIM, which the lines could represent a beam. Which, if you click on this beam, the actual sizes like H beam 130, 150, or the angle or the I beams, the channels, the purlins, it is really with properties. So that's the goal. So once you have that one modeled with a properties, definitely if your model is correct, you can generate a very good schedule, a very good material takeoff. So this is in brief the evolution of BIM. So some of the advances, this one I presented last time. BIM coordination room, the digital fabrication, 3D imaging using the LiDAR scanner, light detection and ranging. So this capture as built condition for alteration works, or even we could use this LiDAR scanner uh, to compare our BIM model with the work in progress on site. So we can have that one. Then point cloud to CTGML. This one almost the same concept with the scanner, but we're using the CTGML, another tool. So the beam cave, this one just to have a more or less realistic um, interaction with other disciplines. You have the computer aided virtual environment. So simply you're still using the 3D model, but all those big boss can join in within that room. Okay, same thing. Of course, the BIM augmented reality. So most of these mentioned, these are actually, if we could apply as contractors, this would be the actual value added to our projects. But of course, it will entail cost to invest. So this is one example. I am really amazed on this one. This is a part of the Singapore Sports Hub. So since the design of that one is so complicated, it is an irregular shaped dome, but the requirement is it should be opening and closing. You need to have a very special column, and you have to. These are pedestals actually, and these are multiple design, not typical. So this is just one example. So you see, they really detailed this one in the model, then they fabricated it as per the model. So that's one really good thing. And Sports Hub is, I think, 6 years or 8 years ago. So Singapore is applying BIM already during that time. Okay. Next, Of course, just to go over, we cannot pass through the BIM fundamentals without going through the BIM maturity. So we have level 0, level 1, level 2, level 3, and level 4. I have presented this one to our company because actually many companies in Singapore are still not yet applying fully or adapting fully the BIM level. So I presented this one, and it's quite funny because even the managers were really dumbfounded. Only level 2 is quite difficult to reach already. See, because level 3, you're already utilizing the cloud CDE, the processes, and 6D. So if your company, current company, or the knowledge of your staff and your company is still in the 2D and 3D, at least you're already in level 1. But if you're using the BIM models, you're partly in level 2, but you need to utilize it in 4D and 5D to, to be a full-fledged level 2. So this is the main goal, the sustainability level 4. Okay. Um, as emphasized here, achieving digital sustainability through integrated BIM and smart FM, or facilities management within an operational digital environment, or ODE. So this one, FM, meaning you're utilizing already your model to detect the level of gases, the level of liquid or oils that in your plant is storing, or in houses, in condominiums, or we call this HDB here in Singapore. It is sustainable if we can utilize our 3D model. We could identify the kind of lights, kind of receptacle use, shower, etc. So that's going to be a digital sustainable practice. Okay, just a review again. We have these 3D, 4D, 5D, 6D, and 7D for the BIM. So 3D, we're quite familiar already. 4D, we're just adding 3D with the schedule. 5D, it is equal to 3D plus the cost or estimate. And 6D, this is sustainability. This one is more on energy analysis. We're using this one. Actually, many companies here or developers here in Singapore are using this um, during conceptual design. They could utilize the how much heat generated if the orientation of our building is this way, that way, etc. So those are the purpose of this energy analysis and this the green building concepts. So they are utilizing this as well. So 7D is FM, facilities management. So to go briefly, what is BIM in Singapore? BIM in Singapore, of course, we are being guided by these international standards. Just for information, um, earlier it is a BSE and ISO. Then these two documents was merged into the PD 19650. This is the ISO guidelines for digital or BIM management in a company. And just a trivia, only 3 companies got the ISO 19650 in Singapore. Although Singapore is really adapting the BIM or very high in BIM adaptability, only 3 companies got this ISO certification 19650. 3 is Ong and Ong. Second is the Sorbana Jurong, and just recently WSP. So all these 3 are consultants or design firms. Okay. So this ISO 19650 standard is an international standard for managing information over the whole life cycle of a built asset using building information modeling or BIM. It contains all the principles and high-level requirements as UK BIM framework and is closely aligned to UK 1192. So if you're really interested in a BIM, or because there's still a lot, so much to learn in this part of the industry. So try to be acquainted with ISO 19650. Of course, Singapore has its own guide. They really provide everything for BIM practitioners so that the practitioners will no longer have much question. They have provided the BIM guide. This is in general. They have provided the BIM essential guide for BIM execution plan. Okay, when I prepared the BEP, as mentioned earlier, this is the reference I used. Then also, yeah, covering the consultants, the archi, the contractors, etc. So we will be dealing on this presentation, today's presentation, I will be dealing more on this, on the BIM Essential Guide for Contractors. And later on, some few inputs on the DfMA or Design for Manufacturing and Assembly. Just a short clip. Okay, so here's the roadmap. These are the challenges they face when they are trying to apply BIM here in Singapore, the lack of demand, entrenched current 2D drafting, lack of pool. So of course, it's more on knowledge. So what they do or what they did, they applied the public sector taking the lead, then promoting the success stories. So actually, they are awarding. These success stories are awards. Projects implementing BIM, then they get awarded. Actually, they have provided millions of dollars as starting fund for SMEs and companies who wants to implement. Then these are the key dates in Singapore, 2013, 2015, and these are the sizes of the project. So initially, BIM e-submission. E-submission is, an automatic submission of your project for approval by the agency, which is the BCA. So that's what we call the BIM e-submission. Now, when it is using BIM, they are requiring a model. So they're going to check your model. You need to submit them. So initially, projects less than 20 and mandatory only for R key. But after a year in 2014, they require it or become mandatory for engineering e-submissions. And in 2015, both. And also even smaller projects. So initially 20,000 square meter, then 2015, they applied it in projects with 5,000 square meter area. Okay. So yeah, this is the same thing, architectural beam, structural, and MEP in 2011 and 2010. So we'll just go through this. This is just a review. Okay, so now going to this design build. So what's the difference? So for design and build project or design bid build project or DBB, it entails the owner or finding separate entities for design and construction. Meaning I am the owner. I'm going to have, this is the usual one. This is the traditional method of project delivery. The owner contracts separately a designer. Then once all the drawings are finished, you're going to have it tendered for the contractor to build. So the design firm is hired to, deliver 100% of these documents or these design drawings. Then the owner or the owner representative is going to have it bid for the contractors. So design, tender, then construction. So that is design, bid, build, or the traditional one. But commonly now in Singapore is the design, build. I'm emphasizing this especially to students. Shout outs to our student participants there. You're going to meet this a lot when you're doing your work already as a professional. Okay, design build. Combine design and construction team with one point of contact for the owner. So in Singapore, we have two common design build projects or setup. One is the contractor will lead the project, And the second one, the architect will lead the project. Normally, the architect here is the consultant. They are, the starting point of a lot of projects here. So design and build is the method to deliver a project in which the design and construction services, again, are contacted by a single entity. So it will be highlighted here in this next slide there. For design and build, you got the owner, then you have the design builder, which normally a main contractor, we call it here. Then if I am the main contractor, I will get a supplier or a subcontractor. Sometimes I will hire the consultant or the designers, but I am the main con. Okay, so I'm the lead here. But for design bid build, the owner needs to have the R key, the construction management, the contractors, and also a lot of suppliers, etc. So this is quite different. A lot of loops for this kind of project. So most of the time, especially most of the projects that I'm involved with, it is a design and build. It's less messy, and as the contractor, we facilitate, or we are the one deciding on who to get for the design and who to get for our subcontractors, like piling contractors or fabricators, etc. Okay, so this is understood. We have highlighted this. We will focus on this one on the later slides. Okay, to understand more, let me share a clip, but I think I forgot to share with sound. So let me close again. Then share. Oops, what happened? Um, then let me share with the sound on. Share sound. Okay. Okay.
So there are actually 3 different methodologies for design and building a project. The traditional method is design, bid, build, where you have an architectural engineering team design the project with the client, goes out for bid, and then the contractor constructs it. The construction manager at risk is that the owner hires the architectural engineering team early in the design. They also hire essentially the general contractor, and they help shepherd the project through the design to value engineer and to get the most out of the owner's money. The other is the design build method, where the contractor is the lead with the architect and engineer as a sub to the contractor, and the contract is between the owner and the contractor. There are pros and cons to all 3. The construction manager at risk has been used quite a bit here in Virginia because it brings the contractor in early, and what then they do is then they bid out to subcontractors. So we have their expertise on what's constructible and what's not, and trying to save the owner money. But then it's pretty much goes through the same design, bid, build flow.
Okay. So it was highlighted there, the same explanation that we had. The design and build, you only need one party as the main focal point before the owner. But the traditional one, design, bid, build, yeah, you need to contract a lot of parties. Okay, so for design and build project in Singapore, these are the common roles and during the certain stages. So we have this conceptual design, schematic design, detail design, construction, as built, facility management. So the role of the employer, stated here, provide requirements. Also during the schematic, they do the design review. During detailed design, they do the design review as well and the approval. So it's simply highlighted here that it is um, a smoother loop, meaning during our design build process for the BIM workflow, especially employer, architect, consulting engineers, and contractors are more or less involved. Yeah, it is emphasized here, more or less involved during these stages of our project. Again, BIM is starting to finish. Okay, from start to delivery or submission, even to the FM facilities management. Okay, so we will not dwell more on this, but if you can see, even contractors are involved already in the concept design. How? They are providing feedback on the initial cost, the initial schedule, constructability. Then also for the schematic design, because they are the one who's going to build it, they can provide, uh, experience-wise design review and feedbacks. So same during detail design and fabrication. Of course, in the as-built, because most of the time the contractors are the one um, handling or submitting these as-built drawings and documentations. Okay, so let's go into our BIM execution plan. So again, for project management professionals, if you're an active PM or involved in a project management team, will be familiar more or less with this as the project brief. Okay, so this is BEP. Guys, meet BEP, the BIM execution plan. Okay, so we're not going to have a lot of slides on this, but we're going to go through the actual BEP that we had in the project. So just to start, the BIM execution plan or the BEP provides the following. So they should provide a clear understanding of the BIM uses on the project and its implementation, meaning what are the objectives, what software should you be using, etc. And then project members or the PM team, PMT, understand their corresponding roles and responsibilities. More or less, we are really emphasizing the role of the BIM manager and BIM coordinator on this document because they are more or less the one handling the BIM aspect of a project. So it is stated there. Same thing as in our project brief. We identify what is the role of a project manager, what is the role of a coordinator, what is the role of our purchaser, what are the roles of our PMT or the project management team, etc. How it is linked to our PMO, etc. So more or less, this is our project management guide for BIM. Then also, BAP should provide the review of the processes for the BIM implementation. So you need to highlight there the schedule of when to conduct coordination meetings, when to submit the drawings, etc. Okay, then the processes, effectiveness, and the definition of the KPI. So we should be able to identify this as the earlier part of our project before we even start. So of course, since this is related to digital aspect of the project, many info on PC specification, what kind of softwares based on the specs provided by the owner or the client should be included. So let's dive in here. So let me share this one. Okay, so by now your screen should have this document. So this is our BIM execution plan, the BEP. So this one we issued and accepted last July 2019. So Let's go into the contents. So for the content, we have the overview. So we have the overview, the project information. Also, we need to highlight the goals and the uses, the key milestones, the key project contacts, the BIM organization, and the basic org chart. Usually, because it is very common practice here in Singapore and also in other part of the world that we have subcontractors or freelancing or subcontracting modelers. So more or less the important thing, if you prepare this, you should know who's the BIM manager, who's the coordinator for your contract, and who's the system administrator if needed. Again, we are highlighting, why did we highlight the design and build project? Because during design and build project, as we already know by now, the key person is the main contractor or the contractor. So if this is a BIM project, the contractor BIM manager would be the one preparing this BEP. So that's one big difference. So if your project is a design and build, whether it is a contractor led or the architecture led, it is the contractor or the arch is going to prepare the building information modeling execution plan. So you'll be the lead. That's why we have this, because we are the contractor of a design build project. So it means once we have this, we're going to give this to our consultant, our designers, for their reference. And also, we're going to relay this info to other project professionals or other stakeholders like the CNS manager, the ENI manager, the piping mechanical managers, construction managers, if they are involved in some of these processes here. Also, if we have our subcontractors like the fabricators, etc. Okay, so that's why we have highlighted that this topic here, we're going to deal with design and build project, and why we have included this particular segment on this lecture, the BAP preparation. Okay, so we're on the same page now. Okay, as the contractor BIM manager, we also provide the workflow, the collaboration meeting, technological infra requirements. So these are the hardware and the software I have mentioned. And also, if your project requires a server, then you should highlight it here. So you should know this stuff even before the project starts. So it is a good practice actually, because you're going to be the one leading even the purchasing aspect of the project related to um, digital scope. Then, of course, you need to identify the standards. So that's why we need to be very familiar with standards in our country and also in the other standards and guidelines like one we have highlighted earlier. Then the model development, etc. Then the coding standard, the naming convention. Yeah, we need to have this model element matrix, collaboration, discipline control checking. So these are the QC, quality control. We should know also how to check, what to check when we receive these models. And of course, it is being highlighted when we are doing a BIM project. We are really, selling it as a well-coordinated project. So we need to have a coordination procedure on the clash detection priority. You can run a clash detection sequence and run a report, but it will take, if you have a very huge project, it will take a lot of time and very um, strong PC. So you need to very wise. You need to be um, wise in selecting this clash detection procedure. So you have to prioritize. Then also the color assignment, the report, sample reports, you need to highlight more or less what you want to be done during the actual execution of the project. Then, of course, the model review procedure. This one, some project does not require, but for this certain project, the client requires 3D model review procedure. So we need to have the review layout and arrangement, design considerations, etc. Then the 4D scheduling. So 4D is the 3D plus the schedule. Next, the as-built and annex. Okay. So these are the color coding. This is the overview of the project. So just a description what this project is about and what is the goal, who are involved. So here we have mentioned that we're going to use a certain software and we're going to conduct model review 30, 60%, and 90% completion of that project. So we need to highlight it here. This info came from the client, but we need to incorporate it here because that is our goal more or less, using this document, using the softwares that we need to comply with this requirement. And also these are the objectives, what a BFP or BEP document contains. Then the project info, more or less, this one is we could use the one provided by Singapore BIM guide, the developer contract type, the estimated project value, this one 52M partial. Then okay, you need to identify the consultants, etc. And also the BIM goals and the uses. So this one, for example, for the BIM use, the goals and the uses, you have high priority on model-based constructibility. So the potential BIM uses are design authoring, 3D coordination, shop drawing preparation. So that is just an example. Then one example of a low BIM goal and use is the virtual site utilization planning and visualization. So you're not really required to do that, but it is an add-on if you can. So design reviews and phase planning. For example, if you have a civil 3D model of your site, then you can do the cut and fill. Then you can have the analysis on where to put your cranes, etc. So that's one example. But for this project, they are not requiring us. So we need to focus on those with high priority, meaning we need to focus on the valves, we need to focus on the detail of the structures because that's one of the high priority. So here, the coordination, the shop drawings. Okay, going forward, we need to identify also the key milestones. So these are some of the key milestones that we have. Now we have the authority submission, the implementation, construction phases, etc. So just a table. So the one glance, the team or the PMT could identify what are the milestones. And these BIM milestones are actually related to the master schedule, but not exactly the same. For example, your master schedule will be, you have the MEP ending at December. So this is construction. So meaning your 3D model should be when it's going to start. So September 16. So your model should be more or less ready before this date. So those are the considerations. Then of course you need the contact info, who are the director, the assistant director, BIM manager, etc. Also, who are your consultants, MEP, CNS, etc. Then the org chart, again, just highlighted here only the manager and coordinators because we are outsourcing. We are giving the modeling of majority of our structures to our fabricator. So here only the BI manager and the coordinator is mentioned. Of course, with their corresponding role. Then here in sentence or paragraph form, you need to identify what are the roles of a BIM manager. So these are the roles of a BM. You should indicate that one. Same in your project brief, you identify the PM role. Also the coordinator, example, utilizes the BIM to perform drawing and design work because most of the time the coordinator also are part of the modeling team. They facilitate coordination between the construction model and also they are conducting these collaboration exchanges of the model data between the consultants and contractors. So also they are assigned to do the model review. And for our project, we need to have, since we are going to have a server, we need to have a system administrator because we have a specific software for this one, for this project. So we need to have an admin. So these are the role. We need to identify that as well in our execution plan. Then the workflow. So we need to provide a very good picture of what's going to be the workflow in our project. So here, highlighted in a design and build project, similar processes is applicable. So each discipline shall pass its own QA, must undergo clash detection, um, clash report to be resolved within a coordination meeting by the BIM manager, coordinators, and discipline leads. Why do we need to include the discipline leads? Because they are the decision makers of our project. So whenever there's a clash, you need to have the decision makers to resolve it. So this is the workflow. Actually, this is the same as mentioned on the statement above. So internal, then proceed to the merge or integrated model, then you conduct a clash report, or clash checking. Clash checking, then you have the clash report, the coordination meeting. Then eventually you'll have a coordinated meeting for construction. So as long as these clashes are not resolved, your coordinated model is not 100%. So you need to go through the same process again until this one reaches no more clashes. Okay, that's the flow. So this document, again, BEP is a live document. You can update anytime if needed. Example, we don't need an admin. We need only a software modeler or a backup one. So we need to identify it here. Or we need to have additional coordinator. You update as well. So here are the schedule of the coordination meeting, collaboration meeting. So fortnightly, every 2 weeks, mostly on this one. So you provide the location, etc. So you identify that. Also, the electronic communication information exchanges. So you need to identify the file type and who's going to be the sender, who's going to be the receiver, and how often. So scheduled. Usually, this is advised weekly, especially if your client is too keen to see weekly progress, especially in your 3D model, then you have to do it scheduled weekly. So you need to freeze the model, then send out. So you need to include it here in the BEP. So for the drawings, usually because these are the one really used by our construction team on site, so this one usually are earlier to be received. Then the model, although it's supposed to be ready, but you need some clash detection, etc. So these are scheduled as well. So it is separate here. And also the file type are different. So maybe IFC, STP, or Revit, so NWD. So all of these for integration so that we can conduct the model review. Then of course, as mentioned, we need to provide also the infra requirements. Infra requirements, the hardware, the workstation, and the server. So we have here, so during this time, we have, I have made a proposal to our project director, but so I provided them with two options. I have researched this. These are the the best specs if you're going to use a Autodesk suite. And also, we need to uh, take a higher specs because we're going to use another software for the piping. So we need to utilize a bigger RAM. So these are the basics. Then eventually, they select whatever vendor that they have uh, chosen. But as one of the BIM managers, or the BIM manager and we're the one giving them the suggestion on this. And also, we're going to have the specs of the server. So it is really good if you are familiar or you have a friend, an IT friend, an IT guy you can consult with before you contact a vendor. So at least you have a better idea. And also, we need to do a lot of research as well. If the Intel Xeon Silver is enough, or do we need a memory card for this server alone, or do we even need this server or something like that? And how many? Also, because the project requires a lot of software, so you need to identify it here as well. So for this specific project, we use the Revit 2019, but actually it is annually we upgrade. Then you need to have the format. We need to highlight the format because that is going to be the exchanges, the data exchange later. Then for the MEP, we're using the Hexagon PPM Smart 3D. Then for the analysis, we have the Cesar 2, the pipe sim. The search analysis, we have the pipenet. And for the analysis, I think structure, we have the Tekla structures. It does not mention. It's supposed to be STAAD. We're using STAADs and ETABs for the ground. But it should be here. You should highlight it here. Then also for the model coordination, what are we going to use? Navis, Tekla, or for the fabrication drawing, Navis, Tekla, Revit, etc. And for the exchanges, we can use the Dropbox, the WeTransfer, and the Interop, and the physical server. So whatever software that you're going to utilize in your project, you need to have it here. You need to have enumerated there. So of course, you need to set up a standard naming convention. Most of the project have this, how to name your project. Then you have this code for electrical, HVAC, etc. Then for the model, you have the zoning, so that you won't have a very huge size model during your integration. So normally one model will have, in our case, this is the old one. We have 7 during that time. But I think we're nearing completion. We already have 12, around 12, because we have additional one. Sometimes we encounter VO or variation orders. So yeah, this is one of the most important thing. If you're using Revit especially and Tekla, you need to have the project base point. So you wonder during integration, you will have a very easy bolt-in of your various models using various softwares, because you have a specific project base point. This is identifying the northing and the easting and the elevation and the angle from the true north. So you need to have this here. Then the model matrices, the LOD. These are just description of what is LOD 100. So LOD is a level of detail. So BIM level of detail. So if it is only 100, normally it is during concept design. During schematic design, you have LOD 200. And if you're going to have the detailed design, it is LOD 300, and so on. So for construction, most of the time, especially for those models with rebars, for example, and your client requires it, you need to have the 350, LOD 350. You need to show those rebars. Okay, going through. So these are the procedure on how we're going to collaborate between Revit and Tekla. So as the lead of the project, you should know how to operate this. And place it here in this document. So the linking. So we're using Tekla, and also we have this Smart 3D, a different software again, different for piping, different for structural. So the model checking. So we need to have this identified visual check, interference check, etc. And the control checking, you need to have that one specified as well, specified. So the clash detection priority, this one I explained earlier. So example, you have the civil model, the structural model, MEP. Civil, normally these are the substructures, the pile caps, the piling, or the slabs. Then you have the structural model like the structures. The we call this civil are the substructure. On top of that one are the superstructure model, which is then we merge them with the MEP. MEP is mechanical, electrical, and piping, but some project call this differently as well. Because some pipings, especially on large projects, they are differentiating the HVAC if they have. But for the piping, like they call it services. They call it services. So that's part also of your model checking. Then you merge, then you have the clash detection, design check, then you identify which one are the priority, medium, low. Then you have the resolution and you combine into your construction model or the federated model, we call it. Then of course, the color coding. This is quite normal in any project. And okay, this is the report. You need to, especially our client, they really wanted to know, oh, what's going to be your format when you're going to have the report. So we need to come up with this one, even though we haven't started yet. If you have a lot of projects already, then you can have your own template, company template from your PMO or project management office. So you can have these templates if needed. So these are the sample clash report and how it's going to be resolved. So some of these description hard clash, then you have the clash point, usually coordinates. Then normally we have the closeout, but for our closeout reports during model review, we only have two columns for screenshot 1 and screenshot 2, then our response. Normally that's what we do for the project. And it was accepted. So the model review procedure, you need to identify as well. So a lot of this. Then zoning. So that's it. You have a lot of info within this BEP. So this part here, these are the color coding normally. Okay, you have the text for your naming, agitator, blowers, buildings, columns, etc. So that's it. You need to identify. These are appendices. Some of this we can copy or we should copy refer from the Singapore BIM guide. So hopefully we can create, I think it is in process. We have the Philippine BIM guide being prepared as well. Okay, so much for this. Let me share again, go back to our slide. I hope everyone is still awake. Okay.
Okay. You're good na, engineer?
No, we're still midway.
All right.
Okay. So okay. So one example of so that is for the BEP. Then let's proceed with the BIM VDC workflow for a CNS design and build project. So these are the current process that we applied in our project. Still not showing. Yeah. This is presented in BCA. So during this time, this is a process we applied in the pipe rack design and construction of a multi-span pipe bridges in Jurong Island. So in this table or in this presentation slide, we have identified the authorities, the consultants, the main contractor, the fabricator, fabrication subcontractor, the erection subcontractor. So the current workflow goes like this. So it started here. The consultant will prepare the design drawings and it will issue it for approval or IFA. Then the authorities will have this reviewed. Then if it is approved, then it will be issued as IFC. But if not, it will go again and revised. Then we'll proceed with the same flow. But if it will be approved and issued as IFC, it will be given to the main contractor. The IFC then sent to subcontractor, which is the fabrication subcon of the steel pipe bridges. Then the fabricator will prepare the construction model. Afterwards, so if you notice also, we have here the design, we have the fabrication stage, and we have the construction stage. Then, once the fabricator prepare the construction model, they will prepare the GA. They will prepare the GA first. So, for info, our fabricator used Tekla. So later on, we will have more appreciation on that one with our second topic. So again, they will prepare the GA. They will send the GA for approval to the main con. Remember, the main con is the focal point of this project. So it is to be received by the main con, but the main contractor will send again to the consultant because they are the main checker to review and approve these drawings and the model. So if it is approved, yes, if it is approved, then it shall be updated in the integrated federated model. But if not, it will go back here. Go back to this procedure. So if it's not approved, no, the fabricator will revise and reissue again, and the flow will continue. But if it is approved and the model is updated, the main contractor will issue approval for shop drawing. So they will say, okay, go ahead, prepare the shop drawings. The GA is approved. Then, if no further queries, normally construction matters, the connection, the bolt clashes with this, etc. So if no further queries, it will proceed to fabrication. So fabrication, of course, we did not emphasize or we didn't highlight anymore the galvanization, pre-welding, assembly, etc., sub-assembly. But this is the main flow. But if we have a query, example here, we have a query, then this will be sent out to the consultant again. Example, hey, we have clashes with 5 bolts. Can we change it to 4? Something like that. So the consultant will, of course, they need to check because it is analyzed. We're running it in the analysis. So if it is approved, then they will send the response, then it will be updated in the model. And from the model, the shop drawing should be updated as well. Then proceed to fabrication. Then it will proceed to pre-erection, meaning for this part, because it is a multi-span pipe bridge, we need to have prefabrication. We need to install first the tower 1, tower 2, then the beam in between or the truss in between. Anyway, later on, I will show you the model. So this is the old process. So we need to identify, during this activity, we have identified what are the pain points. I just want to share with you the pain points. Pain points meaning what are the delays of this procedure. So we have, for the current process, I have identified 7. So we have the time consuming, the number 2 here. The issue for IFC is dependent on the approval stage. Then other members of the PM team may not receive this because it is sent by email. So quite inefficient. So number 3, the latest revision, this one, the receiving of the GA, the latest revision may not be issued together. So Without that, sometimes the fabricator missed out. Then as the main con, we need to, hey, were you able to send the model? Hey, were you able to send the updated GA, etc. Okay, so again, for this, we have 7 pain points. Then from those pain points, um, we propose a better process. So more or less same here, but we are adding a CDE or a common data environment. So from the common data environment, uh, all these recipients could access it right away. So access the IFC from the CDE. So if you notice, we have omitted a lot of processes here. So CDE, oh sorry. Then additional, also we have introduced the ICE meeting. So we have the CDE here, then we have introduced here, the ICE meeting. It means you don't need to send out again and again. Hey, I have a query, I have a query. So during a meeting, which is the ICE, Integrated Concurrent Engineering, during that meeting, especially if attended by the decision makers or the discipline leads, we need to close out these items right away. So no need to, ping pong of these queries. So that's the suggested workflow improvement. So this is what we usually need to do if we want to digitalize our company. Or this is not applicable only in construction, even in manufacturing, even in education, etc. As long as we have a process, we can do this um, process correction. So identifying the current process, then propose a better one. So these are the studies. So again, just sharing with you, this is the workflow of our design and construction of multi-span steel pipe bridges. Okay, to proceed. So that is actually one of the activity when you're doing the VDC. Take note, we're dealing with models, we're dealing with common data environments, etc. But as contractors, we could do so much more. But project constraints. Okay, for BIM contractors, okay, here we go. This is, I think I was able to share this before. So Philippines is not yet included in the adoption of BIM. So a lot of organizations are already pushing, especially um, PCA, Contractors Association, also in coordination with the DPWH. They're preparing. So many documents are being prepared already. A lot of proposals are being prepared already. Some of our projects in the Philippines already using BIM, but how come we're not yet on the map? Especially many talents are already there in the Philippines. It is simply because some of the projects that being catered are abroad as well. And also some of our local projects are using abroad talents. So that's why we cannot, we haven't launched yet. We haven't placed our country here in the BIM map. So that's what's one of our goals here, to educate even our young professionals, our students, our graduating students. Okay, to move forward, these are the benefits of the using BIM for contractors. So reduction of error, collaboration with owners. This one highlighted already, but these are the survey results. I think this is 2013, but more or less, some have changed already. Okay, just to highlight, many of these benefits are still the same. So enhancing the organization's image, reduction of work, cost control. So the biggest one is reduction of errors. Then when asked, percentage of contractors citing BIM benefit as one of the top 3 of their for their organization. So same thing. The top one is the reduction of errors. Top 2 is the collaboration with owners. And top 3 is the enhanced organizational image. Why? Because if your company is adopting this, most probably if especially here in Singapore, um, since the government is requiring them. So if a company have their pool of BIM skilled or their staff are skilled with BIM knowledge, then the likelihood of getting the project of BIM project is big. So it will really help a lot. So that's why Singapore is really driving on educating. But it doesn't stop there because currently here in Singapore, we're already pushing for the IDD, the Integrated Digital Delivery, which is utilization of BIM and VDC, or Virtual Design and Construction. Okay, moving forward, what are the possible barriers? So I have presented this already. So of course, if no demand, why would we adapt? Number 2, no experts or lack of knowledge. Then training, cost, etc. But again, a lot of organizations in the Philippines right now are really pushing to educate our local talents because Filipinos are really fast learners. Filipinos are really adaptable. So once we have injected such technology, eventually will be will be placed there on the map. So these are the common barriers that was faced by contractors or other companies during their BIM journey, their adaptation. Okay, some of these, of course, the OEM, but need to take a look here at the top ones. So no demand. So if the government will require, then most likely it will be adopted. Then trainings, of course, one of these is similar to this webinar. Okay, same thing here. These are the benefits. I think that slide is repeated. Okay, for the contractors, we can utilize our 3D model for logistic planning. So for this example, this one is from the BIM Essential Guide for Contractors. They utilize the site 3D model for the placement of the crane. So you can have this one, play along. You can even do a simulation or a video for this. So that is additional because a lot of your guys, a lot of our um, stakeholders in the project could not really picture out if it's only flat or if it's only 2D. So better visualization and better decision making and judgment of all or many of these parties. So the crane operator, they can justify why in this location, or the PM could say, or the CM could say, no, that is difficult. That is the corner of this one. We have a pipeline there, etc., etc. So that's one big use of this model, site planning for contractors. So this is one very good example also. So they really have because this one could be a product of a civil 3D software or using another software in Bentley. So you'll have the actual elevations or level. So you have the grades here. You will know if it's going down, going up, and you can, of course, you can extract those cut and fill info that you need. So this is for site planning. Same thing, the positioning of those cranes and what are the activities could be made. So if you notice here, this is still soil, but here it is already concrete. Same thing here on this side. Okay, so that is site planning. And constructability review. Of course, you don't want to waste your time to do reworks on site. So upon inspection of the model, maybe you can adjust, especially if you have this knowledge in construction sequence or construction. That's why it's really a good thing, as highlighted by Sir Erdsan earlier. It's really the people. Even though we have these tools, even though we have this technology, it's still the people who's going to decide. So if you don't have the knowledge that this could be converted into this, meaning the the connection would be different, then you cannot suggest, even though how much you're going to look at your model, you can suggest if you don't know this processor. So experience really helps out, knowledge helps out. But of course, efficiency would be increased if you utilize this software. But still, we're the main man, the persons, the engineers, the architects, the MEP professionals. Okay, that is for constructibility review. Another thing, construction detailing, of course. See, this is a product of Tekla. I think this one I grabbed from the Tekla, yeah, because I'm really amazed with how detailed this rebars works here. So I think this is, and of course you can generate a very good documentation shop drawings from these models because they are automated. Earlier, past years, you don't have this, the clamp or the bends of these rebars. But now, see, it's really nice. It's really nice. You can really have it pictured. And it is really important to do this if we want to really, utilize and to have, um, to improve our project sequencing later on, like the PPVC, which I'm going to share in a bit. So again, so that is the construction detailing. Then of course the coordination. A lot of, even though you have multiple disciplines working on a single project, you're expected to have a better coordination, especially if you have the CDE, the Common Data Environment, as highlighted earlier. So as a main contractor, as a contractor, this will be more beneficial on our part because, of course, the clashes and coordination, everyone could picture out. Even though I'm a structural engineer, I can picture out, okay, the ducting is there, okay, the pipeline is there. How come the bend of that pipe is hitting my structure? Something like that. Even for Archi. So the coordination is really, really open. So it is really improved for this uh, using the BIM workflow. So this is one example of another. Sorry, can you give a thumbs up if the audio is okay? So this clip is showing us an example of 4D and 5D BIM. Okay, this is using Bexel Manager. So Bexel Manager is one of, it is suitable for contractors, project management. We can have the 4D and the 5D using this. So I just push forward, just highlighting some of the softwares that we can use. Okay, then here's another one. This is a bit cheaper software. Very good animation. So the client really appreciates how the project management team presented. So this is just a short clip. So for this case, we have the costing here, the logistics, how many workers, how many machinery they have. So this is just one example, just to give everyone an idea. Even the listing. Actually, these models of frames are downloadable. You can do an animation. notice here the workers, machineries are being monitored, and the costing is being monitored as well. So the placement of the domes and the frames. So let me just forward this. So if you notice, you have an assembly line here just close to your actual site area. So that is pre-erection or assembly, then pre-erection, lifting, then readjustment. So cool. Okay, then that is another software, Bexel. That one is the 4D simulator. Then of course, one of the most commonly used because it's quite cheap. Autodesk Navisworks. So let me play this for you. So this is just a 1 minute clip. I think we're still on time. So this is one example of a 4D simulation. So later on, I'm going to show everyone just a quick procedure on how to utilize Navisworks to create such animation. Just a basic one, how we're going to connect the object, the 3D object, to the schedule. So we're going to see that one later. That's why we're highlighting this software as well. So later on, since this is one of the most commonly used software, so I will be highlighting some of the just a quick procedure on how to prepare 4D, 5D, and clash detection using this software. Okay. So now proceeding with the Navisworks 4D simulation timeliner. So 4D again is a 3D beam scheduling data. So we are highlighting this because these are part of the add-ons, the value you can add to your project, especially if you are a contractor. So 4D, the scheduling data or the construction sequence added to the components, which will build in detail as the project progresses. So this helps in the actual program information, the visualization showing how the project develops. So I have 3 buttons here. We'll just fast forward this. These are the workshop clips I prepared during my Navisworks workshop here in Singapore I have conducted. So is it showing? Okay, so it means I need to have that one as new share. Mm. Okay, the first clip will be showing us a timeliner appearance. But I think it's not yet shared. Okay, let me share that again. Screen 2. So it's not playing. Okay. So this is a 2-minute clip, but so as mentioned earlier, we're here in Navisworks Manage. Let me start again. We're going to pick our 3D model. So this is our 3D model. I think this is a hospital. We have columns, we have walls, we have floor slabs, and we have the pile caps. Then opening this selection tree on top. Opening the selection tree here. Then we'll open the timeliner here. If you can see my mouse arrow blinking. So that is the timeliner. Then we will connect. We'll connect the object, which is here in the tree, on the side, on the left side. We will connect with our schedule. So we can have the option of data source, then we have the configuration, then the simulation. So later on, our main goal is to have this animated using our schedule. So appearance definition, just identify the colors, etc. Example, when it is being constructed, then once it is constructed, so it's going to be solid color. Then the appearance, just changing this. This is because we're aiming for a good animation. Okay, then renaming the appearance. Then the start appearance and the end appearance. Okay, so that is clip number 1. Now, for clip number 2, we already have the, no, this doesn't have any audio. So now we're going to key in the data source. Interestingly, it is still blank, but we're going to connect the schedule. So we add the task as highlighted. For the data source, we're going to pick. So we have the option here to select a project Microsoft project or an Excel file, .csv. So for this example, we have the sample structural. Then we'll just change some of these names here. The goal of this clip is for us to see how we're going to connect the schedule that we have. So remember, we already placed in a schedule in an Excel sheet. So this is 7 minutes. So let's just fast forward. So you rebuild the task hierarchy. Once you key in that one, it should be propagated here. Once you place the task, these are the content of your Excel file, the foundation piles, footing, etc. Now, we're going to connect this to your 3D objects. So if you notice, you have the plan start, the plan finish. You also have here the animation here on the right side. So as long as your task is changed to construct, it will later on show as a clip, because those are the task type also of your model. Okay, then we will attach the objects. Okay, let me just fast forward. Okay, going to home, you have the selection tree. Now, clicking on, I think we started here with column, then you can pick one by one, or you can select the same here on top. So if you notice, you just simply click here on the tree, then all of your piles are selected. Then once that is okay, you save the selection set, then you rename it. So we rename it piles. Then we will have another selection set for the pile caps and so on. Then after this, once we're done, okay, let me forward so that we can cover more. So yeah, we need to have this group and saved. So save selections. Then later on, we will have that one matched. Okay, I'm going to forward this. So if you notice, you already have a set for piles, pile caps, slab on grade, ground floor columns, etc., etc. And your schedule here or the task here are prepared already. Now we will just simply attach those selection set. Let me go to the attachment of the selection set. Okay, here. Okay, take a look at this part here. Attach, just simply click. Then attach set. Those are prepared already by you. File caps and so on. Okay, so you see you already have your schedule and your attachment of your model is being done. So this clip shows that here. So we'll just let him finish. And after that is done, you can run your simulation later. Okay. So the schedule, then you can simulate. So simulate, it is already running. Then of course you can record this one and you can send out to your client or during your presentation the .avi file or the movie file. So you want extra information, you can have it here. The weeks and the task, it's going to be highlighted on top. So you're going to have your percentage, your foundation piles, how much was constructed, etc. The pile caps, the ground slab. So it depends on how you really place in this model to your schedule. So, so if you place it incorrectly or attach it incorrectly, then of course your simulation will be incorrect as well. Okay, that's it. Let me end this one. And let me share again our main slide. Okay, I hope you enjoyed that simulation. Okay, it's not yet done. Okay, so moving forward, 5D beam. I think we don't have much time, so we'll just end here for the discussion. But 5D beam, I will not show the simulation. But this is how you prepare it. You have a model, then you also have, you can have the takeoff and export it to your Excel. And I want to highlight the clash detective or the clash checking. So I only have one video here, I hope. Okay, with the clash results. So let me play this and share that again. Okay, so the model is showing. So I think in this model we have three discipline, the structure, the piping. But for this specific example, we're going to have um, between MEP. So we have three, Archi, MEP. So setting out our test. So we're going to compare workshop model. So we're simply selecting the discipline that we want to have the clash checked. So let me forward this. So in selection A, we have selected Archi. In selection B here, we're going to select this pipe which is under the MEP. So, but since it has too many, so we'll just select the same and same type. So it will be highlighted. Then use the current selection and it will be highlighted here in the selection B tab. Then run. So we need to change the clearance. We can identify 10 mm clearance, etc. We can highlight that one. Okay, then, oops, too much. Okay, so once that is run, we're going to have this report. So based on this one, the number of clashes are 359. So you can highlight this in the model. So highlight, then you can hide as well. Then of course, what's the use of this if you cannot export this one to a report? So once seeing this, we can have that one. Then later on, all these clashes, we can export to a report and assign whoever should be the one addressing this or closing this. Okay. So that is just an example of a clash report, clash checking using our Navisworks. Then actually we can export the report here. Of course, the status also you can change. What's important thing here is you can export this once you have run the clash report. You can export that one to Excel or HTML. Okay, so that's it. Then let me go back to our slides. We're almost done. Okay, for the meetings and model reviews, we will not go further. It is we have highlighted this already during our tour in a BEP. So we identified the meetings, the coordination meetings, and its importance. So of course, the model reviews. We can use a lot of tools, but most of the time in our company, in our project, we are using the Navisworks Manage to conduct a model review. So BIM to Field, this is another add-on or another another additional or value added to our using BIM for contractors. So let me play this.
What on earth is BIM to Field? Well, we're going to tell you in this video, but first, it's important to understand BIM itself. Here's a quick recap. BIM is the process of creating information models or data sets formed of graphical and non-graphical information in a shared digital space known as a common data environment. The information builds in richness as the project stages progress until that complete data set is handed over to the client at completion. Information models give project teams highly accurate, well-structured and coordinated data about the assets they are designing, constructing and maintaining, whether that's a road, a railway, a structure or a building. That data can be used to support takeoff and pricing, programming, or for developing fabrication plans, amongst many other things. Working in this way enables proposals to be tested and honed virtually first, before heading out to site. But how do you transpose that highly accurate digital data into accurate construction in a real site environment? Well, traditionally, this is where the process has reverted to manual, a lot of the accurate ways of doing this. Tools such as the robotic total station by Trimble MEP enable you to import model data to a handheld tablet device in the field. That data is then relayed to the robotic total station that provides accurate setting out from the information model using its laser measuring system to a tolerance of 2 millimeters. This technology corrects for points on uneven surfaces and locates wall penetrations. Any variations to the model data due to changing conditions on site can be logged and fed back as as-built data to the project team. Even just from an efficiency point of view, this enables one person to set out 5 times as many points as a 2-person team using manual methods. Of course, the technology is operated by a person and uses model data that's been entered by the project team, but the chances for human error are greatly reduced. Beyond the setting out, there are a number of applications that enable you to take information models, enable you to access data for the space you're in, or to record as-built data and feed it back to the model. Take away from this video, not just an understanding of what people mean when they say BIM to field, but recognition of why it's important. What's the point of investing in that accuracy at the front end of the process if you don't use that accuracy to actually construct with out on site? If you enjoyed this video, don't forget to share it with a friend.
Okay, so that's one product from Tremble. Now I'm going to show you, I think this one is a brief presentation by Leica. They're one of the major player also of our scanner. So just to give us an idea. So this is Field to BIM. So field and BIM. So as data is acquisition, as is data processing, then 3D data and analysis. So these are the three products usually presented by Leica, the Cyclone. Then it will be converted to be read by the BIM authoring tools or the modeling tools using this CloudWorks and Jetstream. Then you have the real world application. You have the IFC and this, I think that is the Cyclone. So this is just an example of Field to BIM, a product by Leica. Then next, this one is a bit detailed description of Leica's Cyclone 3DR. Actually,
I'm going to start with the CloudWorks and building extractor demonstration.
We're having a study. Currently, I'm having a study for the implementation of this one in our company as a contractor. So we're trying to gauge the pros and cons of having this one, since this is quite costly also, but a very good investment, since you can cover a lot of projects, not only A&A, but also even EPC project or engineering, procurement, construction, commissioning of existing facilities. So if you have this one, it's an advantage to you. But of course, there's an option also to rent out. But again, the usefulness and the accuracy of this tool is amazing.
Session. Let me go to my.
So this is just a demo presentation.
CloudWorks. Sorry, this is a Cyclone 3DR. Okay, so I'm going to choose that. Sorry. All right. So what I'm going to do is this tools in various of third-party or even other software. You notice is this seamless integration. You will get the same function. You can actually search whatever file that you want. This is basically just a 4 GB, quite small. And you will get all the information of the coordinate system as well. I'm just going to pick this port identity, right? So from here, what I'm going to do, this is for those of you that notice, this is one of the national monuments that we have in Malaysia. So I'm going to go and click, go to the top view, and you'll notice that in order for me to align it, to orient it to my view, what I can do is I can just go and click create UCS. I'm going to click 2 point. Now I can just pick, say for example, I'm going to pick somewhere.
So you can do the scanning actual, but you still need to have some post-processing.
Somewhere here. Limit box.
So this is one good example.
You can 3DR is actually when you to work with this limit box. Now you don't have to go to behind of this surface here. You don't have to orbit behind here. What you can do is, let's say for example, I want to adjust this. Right, I just press. Now, in order for you to work with this point cloud, you need to convert it into a Cyclone 3DR point cloud. So I'm going to click on that, right? And I'm just going to click OK. Now, before I'm going to click OK, you'll notice that we have this function, image conversion. So what will happen on it? And as for now, I don't have R. And once I have this, the next thing what I'm going to do is I can actually just click and create a surface modeling. This is where I can use the building extractor.
You can
click
create
on that
the
and just
3D
let
model
it
and convert it into the one usable in our,
click on that,
authoring tools.
How intelligent or automation function in Cyclone 3DR that you can just give it to the software, but just to show you how many.
So a few clicks and it
use
will be
this
created.
the
So
layout
this is post-process.
of that monument. And what we can do is we can actually just send it over to AutoCAD. And before I go to the AutoCAD, I'm going to put it side by side just so you can see it. I'm going to click AutoCAD. Right, so I'm just going to select that outline, right click, I'm going to click send to, click on the AutoCAD, it will automatically appear in here. And as for some of you that already know, AutoCAD is one of the software that is really good for you to create documentation, etc.
So that is like a product.
Oh,
Then there's another clip just to show a bit of DfMA. We're almost done.
interoperability between
Just
one
give me
software,
a
our
few
software.
more minutes. This is DfMA, designed for manufacturing and assembly. One of the, again, getting tracked using the 3D modeling accuracy or the BIM processes. So this one example is GORE Engineering. I think this is in Canada. So they have identified the benefits of manufacturing environment offsite, then increase safety. This is Australia project. So this is how they they fabricate it offsite. So that is phase 2. Then the glazing and the cladding. So because of the accuracy of the software, and of course our skills as designers and engineers, we can fully utilize this using process flow. So this becomes modular. So the only thing you need to do on site is more or less on the lifting. The cladding is already there. Some of the considerations here is the lifting weight, and of course the size of your frame, the angle of your for this case, it is a two sets of handling. So this is one example of the prefabricated, the design for manufacturing and assembly. So the speed of doing things really is exceptional because of this process flow. But without the modeling, the actual modeling, it's quite difficult. The accuracy won't be met. So as a contractor also, if you can think out of the box using this procedure, existing processes, then it would be better, especially if it is helping our project being constructed in lesser time, lesser budget. So meaning we're being more efficient. Only 2 cranes. Okay, and the PPVC. So I think I have 2 samples here of PPVC. This soil build, one of a contractors here in Singapore as well. We could have a better understanding of the integrated construction and prefabrication. So they are utilizing Tekla.
The Soil Build Prefabrication Innovation Hub is a compact building that consists of 2 levels of production floors with a high degree of mechanization and an office on the 3rd level. We focus primarily on producing prefabricated construction elements with an option to assemble them to form volumetric components. The move to ICPH has enabled us to expand our prefabrication capabilities. Not only are we able to increase productivity substantially, we are also able to produce more complex components in a shorter period of time. SoilBuild is at the forefront of embracing digital technology in building a robust design for manufacturing and assembly ecosystem. Besides building more efficiently, we also need to start building more intelligently. Tekla Structures, with its open BIM approach, gives us the flexibility to communicate with various project stakeholders and software languages, allowing us to
Actually, a lot
exchange
of
digital
Filipinos
information
are
across the project value chain
part of
efficiently.
Tekla Structures allows us to build up the level of details in the BIM model according to the design requirement. Digital information can then be extracted and exported in formats that enables BIM modelers to collaborate out of the engineering office with the production crew and eventually with the site installers through the same digital information that was produced from the high LOD Tekla BIM model. Basically, models are enlarged and analyzed during meetings to remove any potential problems that may arise during the production stage. Doing so ensures a smooth process throughout the production cycle, from start to finish. Once the model is approved from an engineering perspective, it will then be released for production. The Tekla constructible model contains all key information of the elements, which are needed for production and tracking purposes. Data is converted and transferred seamlessly from the Tekla model to the ARP system, and then over to the master computer system, facilitating the flow of information and creating a complete and wholesome production cycle through our automated circulation
the
plant.
files sent from the
In
model.
essence, the Tekla system further allows dedicated user access rights and tracking system for accountability purposes. Tekla support team is also very proactive in continuously improving the software and customizing it according to our local needs.
Working on design solutions is now less tedious and more systematic. Tekla provides a platform where collaborative sharing can take. ICPH enhances our image, innovate and adopt.
Okay, let me end this session with this video from PPVC.
Okay. Thank you so much, Engineer Romualdo, for that presentation. I hope the participants learned a lot, and of course, they will apply it in their practice. So before we have our lunch, I know all of you are already hungry. We will have a panel session. You may ask Engineer